Hi, and welcome to day 5 of Python Challenge. And today we're going to talk about loops and iteration. So without further ado, let's start. So basically we do loops in order to have a couple of repeated steps. Basically, when we have a couple of steps that we want to do, that's when you're going to use the loops. So in this program, we have a while loop, and the condition of the while loop is if n is greater than 0, then we will print the n and we will deduct 1 from n. So that's the example of a while loop that we have. At the beginning, we assign number 5 to the variable n. For the first time, it matches this statement, so we go to these operations which are mentioned here, and this operation will happen till this equation is true. So in other words, we will have one loop when n is equal 5, another one when n is equal 4, another one when n is equal 3, 2, and 1. When n is less than 0, less than or equal than 0, we will get out of this loop, and or we will get out of the this while block, which is this block here, and we will continue to parse to the next commands, which is print blast off, and finally we're going to print n, which is 0 in this case. So the example that we mentioned previously was a finite loop, which means that as it runs for 5 times, and after that it will get out of the loop block. Here is an example of an infinite loop, which means that this loop will run forever basically. So in this example, like previously, we assign 5 to variable n, and we say that while n is greater than 0, print ladder and print rinse basically, and we don't have any other statement to decrease the n. So after the first run, it will go back again, and this condition is true, and is still 5, is still greater than 0, and we will do this to print commands, and it just runs and runs and runs till eventually the computer shuts off, or we run off memory, or basically by definition this is an infinite loop. So the problem is we should be very aware when we define loops in our code. We should be aware that they should not run infinitely, because they will consume a lot of resources, memory, CPU, sometimes hard drive, and they create problem basically. So we have to be aware that our loops at some point will be is a finite loop, and we get out of that loop block at some point. So basically that's another loop here that we have. The problem with this one is, so at the beginning we assign 0 to variable n. So when it comes to the loop condition is while n is greater than 0. This condition never is true under these circumstances, so we never actually go inside this while loop block. So this block will be entirely bypassed, and we will run to the very end, and we're going to print this one, which is going to be dry off. So in this situation, we did not even enter the while loop, and we did not run any of the commands associated with the loop. So now we're going to talk about how we can get out of the loop. So one of the reserved words in Python is break. So let's say we have our statement is while true, which means this loop is going to always run. So unless we're going to use a break command, which is here. So this loop is going to run continuously. We're going to get input. If the input is equal to done, we're going to break. And by breaking means that we will get out of the loop at the breakpoint, and we will go out of the block. Basically, we will run the next command, which is done, print done. If this statement is not true, if this if statement doesn't apply, which means that we haven't typed done, this block will be bypassed, and we will print the input that we received from the user, basically. So just to recap again, by break we will get out of the loop block, and whatever is after the break in the loop block will be bypassed. So in this case, an example would be we type hello there, because we don't have any done, we just gonna bypass this section and it will print hello there. When we type finished, again this part will be bypassed, we will print the line which is finished. And when we type done, this is true, this if statement will be true, the line is equal to done, and we get out of the loop block, and we're going to print done here. So again, just to so the analogy that the professor used here was about transporter, basically, in Star Trek. So the analogy is the break command is basically bypass whatever else is in the loop block, and it will kind of transport the program to the first command after the loop. So the other way that we can manipulate the sequence of a loop is the continue command. So the continue statement ends the current iteration and jump to the top of the loop and start the next iteration. So if you remember again, the break statement would get out of the loop, but the continue statement will go to the back of the loop. But on both instances, whatever is after break or whatever is after continue in the loop block will not be executed, and it will be bypassed. So in this case, this part is like before. If we get to it done, we will break out of the loop. If the input is equal to #, we just skip this part. So the example would be we type hello there. Hello there doesn't match this if statement, doesn't match this if statement, is not equal to number sign, is not equal to done. So it's going to just print the input, which is hello there. The next line is pound don't print this, and because the first line is the first character is the pound sign, it will come to the, it will match this statement and it will continue, so it doesn't print anything and it go back to the top of the loop. So in this example we don't have any output here. When we have the next line is going to be print this. Again, it doesn't match any of these two if statements, so it's just going to print it. And the last one is done. It matches this statement. This is this if statement, and eventually gets out of the loop block. So again, continue is a statement that will take this to the top of the loop and start from beginning. So here is another example. Again, we can see the flow chart. If this statement is true, we're going to do something at the this is basically the while loop block. If this statement is true, we're going to do some stuff. If we get to continue, we go back to the beginning of the loop, and that's how we can manipulate the normal sequence of the loop with using continue and break. So infinite loops, we call the while loop as an infinite loop because they keep going and going and going until the logical condition becomes false. So basically this condition, until this becomes false, this is going to be an infinite loop basically, unless we use continue or break. So the loops that we have seen, they are pretty easy to maintain, and we can terminate them. Otherwise, they will become infinite loops. Yes. So now we're gonna go to definite loops. So there are a couple of times that we need to use definite loops. One of them is we have a list of items and we want to do a certain task for each of that member of that list. So we have like a finite set of things and we want to do a task for that number of finite member. Also the other so we can write a loop to run the loop once for each of the item in a set of Python using for construct. So again, when we get a list, we can use the combination of for and the list to make sure that we have a loop for the number of members that are in the list that we have. This is an example. So here we have for I in this block of numbers. So here we have 5 numbers in this string. What we're gonna do is we're gonna run this loop for 5 times. So for I in this string, we're gonna print I. So the first time we're gonna print I is equal to 5, then I is equal to 4, 3, 2, 1. So this is gonna be the output of this. And after this, we get to the end of this string, we get out of the loop block, and we're gonna print last stuff at the end of this. And this is a simple definite loop. Okay. So here we have another one. So as we discussed previously, we're going to use mnemonic names, which means that we're going to use the variables that are making sense to us. So here we use a variable called friends, and friends has a string of 3 names: Joseph, Glenn, and Sally. And we're going to have a loop for these variables basically. So for friend in friends, meaning that we have this string which is called friends, and for each of those name that is inside of it, which are 3 of them, we're going to print Happy New Year and friend. And every time that we do this loop, the friend moves forward in that string of names basically. So the first time the friend is going to be Joseph, the second time is going to be Glenn, third time is going to be Sally. So output would be Happy New Year Joseph, Happy New Year Glenn, Happy New Year Sally, and after that 3 times we get out of that loop and we're going to print done. So here again, going back to the similar example, what we are saying here is for I in this string, print I, and at the end of it, print blast off. So the flowchart is like we get to this deciding point, which is this is basically the beginning of the loop. We're asking the questions: are we done? And are we done means that are we at the end of this string here? If it's no, we just move I one more and we're going to print it. If we are getting to the end of it, which means that we have done through this 5 times, we will get out of the loop block, and we're going to print the command after the loop block, which is print blast off. So here we just have some formal definitions. So in the previous example, we have I for I in this sequence. The I is going to be the iteration variable, which means that it's going to, the first time is going to be 5, then 4, 3, 2, and 1. Basically, this sequence that we have is going to be the in this example, it's going to be 5-element sequence. So the 4 will go through each of the elements of it. The block body here is basically whatever commands that we want to be executed inside this loop. In this case, it's going to be print I, and basically that's it. We just move this iteration variable through this sequence that we have, and for each sequence we're going to print this I as the output of this block. So again, the iteration variable, in this case the I, will iterate through the sequence, which is an order set at this example. The block is whatever codes that's executed within the loop, and the iteration variables again move from the beginning at the very left of it to the very right of this sequence that we have. Again, this is like the output of it. So at the beginning, I is equal to 5. We're going to print it. Then I equals 4. We're going to print it. 3, print it. 2, print it. 1, print it. And then we get out of the iteration loop. I'm sorry, iteration block. So we're going to talk about the idioms, the word that we use, or what we do basically in the loops. we have to, so here the trick is knowing something about the whole loop when you are stuck writing code that only sees one entry at a time. So the idea is when we do this for thing in data is that we want to, let's say we have an array of numbers. We want to look one by one and examine each member of that sequence individually. So that's why we use loops basically. So at the beginning we set some variable to initial values, then we do four things in data, then this is our block of tasks that we're going to do in the loop. For example, look for something or do something to each entry separately, updating a variable. Then after we get out of this for loop, we do something else, look at the variable, for example. Okay, so here we have another set that we want to loop through it. In this piece of code, we're just going to print before, that's at the beginning, and we're going to say for thing in this set, print the thing. So the thing at the beginning is going to be 9, then 41, 12, 3, 74, 15. And we're going to have all of them here. At the beginning we have print before, which will be here. After this loop is going to run for 6 times. After it reaches the end of the set, is going to print after. So this is going to be our output in this example. So the example that we have here is we're going to show some numbers and a sequence of numbers, and the idea is we're going to find out what is the largest number that we will see. So ready? 1, 2, 3. Okay, so what was the largest number? So this is hopefully, I mean, it was easy for me. I don't know, some people might be easier for them, so some people might be difficult for them, but the idea was we went through this set of numbers one by one, and the way that I went through it was I saw 3 and I said, okay, 3 is the largest number right now. Then I saw 41 and I said, okay, 41 is bigger than 3, so that would be my largest number. Then I saw 12 and I said, okay, 41 is still bigger than 12, so this stays the largest number. The same applies to 9, but 74 is of course bigger than 41, so I keep this 74 as the largest number. And for 15, of course, 74 is greater than 15, so 74 is the largest number in this set. So if you notice, when we saw that in sequence, we did a comparison between each 2 numbers and chose the largest number and kept that largest number, moved to the next one, and we moved to the end. This is kind of the same procedure that computers, I mean, this piece of code that we're gonna develop is gonna do. So at the beginning, we're gonna have a largest so far variable. We're just gonna assign it -1 because we are sure that there is at least one number greater than this, knowing that our number are all positive. So that should be like the prerequisite to this assignment, that we have -1 assigned to this. We see number 3. 3 is bigger than -1. We put it here, so 3 right now is our largest number so far. We go to 41, is bigger than 3, so the 41 stays here. 12 is less than that, change it. 9 doesn't change it at all also. Oops, 74 is bigger than 41, so 74 will replace 41. And finally 74 is still bigger than 15, so 74 stays as a largest number. So this is kind of the mindset or the procedure, let's say, that that is used for finding the largest number in a program. So here is the actual code. So we assign largest so far, we assign -1 to largest so far. We're going to print before largest so far, which is going to give us before -1, and we're going to run a for loop, and we call it denum, so for denum in this set. If the number that we choose is greater than largest so far, we're going to assign the num to the largest so far. After that, we're going to print the largest so far value. I'm sorry, we're going to print the largest so far value and the number that we are moving through this for loop. So we start with 9. 9 is greater than -1, so we place 9 to the variable largest so far. So the output would be 9 space 9. When we run again, we get to 41. 41 would be the largest one, replacing 9. We have 41 and 41. When we get to 12, 41 is still higher, so we have the output would be 41 and 12. The same applies to 41 compared to 3, but in 74, 74 would be the largest number, and it stays largest number in comparison to 15. And after that, after this set is done, we get out of it, and we're going to print after and the largest so far, which is 74. Okay, so we're gonna have some more loop patterns here. What we want to do here is we want to count the number. We want to count in the loop. So at the beginning, in this example, we're gonna assign 0 to the variable Zork. We're gonna print before and the value of Zork, which is 0. So we're gonna have before 0 here. Our loop is like for thing in the set. So we start from 9 going to 15. If Zork, I'm sorry, for this thing in this set, add 1 to Zork and save it into the Zork. So for the first time, our thing is 9, our Zork is 1. So we're gonna have 1 and 9. The second time, we're gonna add another 1 to increment Zork. So it's gonna be 2 and 41. This time we moved 1 to the right. Now we're gonna move to 12. Our Zork is gonna be 3 and the thing is gonna be 12. Here we're gonna have 4 and 3. Here we're gonna have 5 and 74. Here we're gonna have 6 and 15. And after this, we will get out of the loop and we're gonna print after Zork, which is after, and the value of it is 6. So we this is just another example that in this loop we ran 6 times, and we could count how many times we run it, and we keep track of, basically in this example we count the number of digits that we had in our for set. Okay, so here, so the previous example was counting how many members a set has. Here, what we're gonna do, we're gonna have the addition. So what we're gonna do is we're gonna add up the member of each set, and we're gonna end up with the sum of the whole number in the set. So here we again, like previous example, we assign 0 to Zork. We're gonna say before, we're gonna say print before Zork, so the before is gonna be 0. We're gonna talk about, so we get to the loop, we say for thing in this set, and thing is gonna be is gonna parse through all of these sets. We're gonna have Zork, which is 0. Here actually Zork plus the thing, so we're gonna have 0 plus 9 in this example, and we put it to the 9. We put it in the Zork, and we're gonna print Zork, which is 9, and the thing, which is 9 again. In this round. In the second iteration, we're gonna have 41 as thing. So we're gonna have 41 added to the Zork, which was initially 9. It was initially 0, now it's 9. So 9 plus 41 is gonna be 50. We're gonna have 50 and 41 as output. Again, we're gonna add to the same thing. We're gonna add 12. It's gonna be 62 and 12. We're gonna add 3 to that. So the thing is 3. We're gonna add 3 to 62, which is 65. We're gonna add 74 here. So the thing is 74, and we added 74 to 65. The output is 139 and 74. And finally, we're gonna add 15 to it, which gives us 154 and 15 as a thing, and we get out of the loop, and we're gonna print after and Zork. And Zork at the end of this loop has the sum of all members of this set. So this is a way to use loop to calculate the sum of a set. So here we're gonna use the loop to find the average in a loop. What we're gonna say is we're gonna assign 0 to both count and sum. We're gonna print before and the value of count and the value of sum, which is 0, 0. So we will have before 0, 0. We're gonna have a loop statement for that set, and we're gonna, inside the loop, we're gonna say that, okay, for each time we run this, add 1 to the count and save it as a count. And we're gonna have the value added to the sum. In this case, sum is 0, and assign that to the sum again. So as this loop goes to the iterate, basically, we're gonna have the number of member of this set, and we're gonna have the sum of this set. At the end of each iteration, we're gonna print the value of count, value of sum, value and the value itself, which is which set of the numbers we are iterating through in this set. So here's going to be our numbers, and after this set runs for 6 times, we get out of the loop, and we're going to print after. We're going to have the count, we're going to have the sum, and we're going to have the sum divided by count, which in this case is 25.666, which is our average of the number that we saw in the set. So this is another example of how can we use a for statement or a loop statement to calculate an average in a given set. Okay, so here we're gonna do another example. In this example, we're gonna find, we're gonna filter. Basically, what we're gonna do, we're gonna say, what are the large value are. I'm sorry. We're gonna say that we're gonna find members that are greater than a specific value. So we're gonna start with the print before. So we have before here. We're gonna have a for loop for this set. If the value is greater than 20, we're gonna print large number and the value. So the first time we ran it, we have 9. 9 is not greater than 20, so this will not be executed. We will go to the next iteration. 41 is greater than 20, so we're gonna have, we will fall into this if statement. We're gonna have print large number and value. So large number and value is 41. 12 is not greater than 20. We go back again. 3 is not. We iterate again. 74 is. We're gonna print this again. So print. We're gonna have large number is 74. And we're gonna iterate one more time. We get to 15, and it is basically not matching that if statement, and we get out of the loop, and we're going to print after. So this is going to be our output. In this case, we found the numbers which were greater than a certain value. So another example that we can use loop is search by using a Boolean variable. So Boolean variables, they can be true or false. In this case, we assign false to the variable called found, and we're going to say that print before the value of found. So we're going to have before, and we're going to have false. So for this loop, if the value is equal to 3, then we're gonna have change our found to true. So basically, this piece of code is saying that if we find number 3, we're gonna change our found variable, which is a Boolean, which has true or false, to true. So 9 is not equal to 3, it doesn't run, it just print found and value. So the found is false, value is 9. The next one is 41, we have the same. The next one is 12, is the same. The next one is 3, so we're gonna have true and value of 3. In this case, we don't have any mechanism to revert the Boolean to false. So the Boolean is going to stay true, and we're going to have the next numbers in the set. And after that, we're going to print it, which is going to show as after and true. So because we have a true, it means that we saw a certain number, which in this case was 3. So we talked about how to find the biggest number, but we're gonna see if we can find the smallest number with the same concept that we had in the finding the largest number, which unfortunately is not gonna work because we need to look at this problem in a different way. We have to solve it in a different way that we solve the largest number. So the way that we're going to solve it is is not this way, this will not give us the desired outcome. So the way that we're going to use it is basically using another type, which is called none. So none is basically a constant, and the constant that indicates emptiness and non-existence. And it's a special basically character, is a reserved character, and in this example we assign none to the smallest, so which means that we haven't seen the smallest yet. That's how we can interpret this statement. We're gonna print before, so we just have print we're just gonna have before as output here. Our loop is gonna run through this set, and if smallest is none, so in this case, so let's see what is means. So is like is stronger than equal sign. So, and when we talk about equal sign, we talk about double equal. So basically, what is does is make sure is the value and the type of our variables are identical or not, and this gives us a true or false. So in this case, our value is 9, our smallest is equal to 9, and that's a true statement because at the beginning we assign none to the smallest, and this statement is true. So at these circumstances we put our value, which is 9, to our smallest. So, and that's part of the if statement. Now else if doesn't apply here, of course, and we go to print statement, which is smallest and value. So smallest, we assign 9 to it, and value is 9, so the output is going to be 9, 9. We go to the next iteration, we get to 41. This statement is not true, so we go here, and here we check if 41 is smaller than 9, which is not true. So we're going to print smallest, which is 9, and the value, which is 41. We go to the next iteration, we get to 12. Is this statement doesn't match here? Is 12 less than 9? That's not true. So we're gonna just print smallest, which is 9, and the value, which is 12. We go to the next one, we get to 3. This if statement doesn't run because it's not true. We get to else if, and is 3 less than 9? Yes. So we're gonna assign 3 to the smallest. We're gonna print smallest and value. In this case we have 3, 3. We go to the next one, 74. 74 is not less than 3. We go up. Here we're just gonna print 3 and 74. Then we get to 15. 15 is not smaller than 3. Again, we're gonna have print 3 and 15, and after that we get out of the loop, and we have after and the smallest, which is 3. So that's how we can solve the finding the smallest value in the set. Okay, so we're going to talk about a bit about is and is not operators. So basically, the is a logical expression, which means that if the value and type of those variable identical, so it's stronger than double equal. So double equal just says if the values of these two variables are equal, but is stronger, and in the is example we have to have identical value and type of variables. The same applies to is not also. So we can have an operator called is not, and it can see if two variable has the same type and value. So here in this example, actually that's exactly the previous example. Just when we have is, we just make sure that again we just want to make sure that that is talking about the value and type, and double equal sign is only about talking about the value of the variables. Okay, so today we talked about the while loops, the indefinite one. We talked about how to get out of it using break or continue. We talked about non-constant and variables, which is kind of like a special type of constant and indicates emptiness and non-existence. We talked about for loops, the one that are definite, the one that goes through a specific set, a finite set. We talked about iteration variables, we talked about loop idiom, and we saw how we can find the largest or smallest number in a set. As always, this was slides from Dr. Charles Severance, and that's it. Thank you so much for watching and listening to this video.